it could be any kind of a project. It could be, in the example I showed earlier, it was Hugo, and then as soon as you make a change, it does the deploy to to AWS S3. And so that's one kind of continuous delivery. But then another one could be the machine learning example. And a good example of that would be, let's say, Flask with Google Cloud or with Azure, either one. But let's take Flask to begin with. So you put these changes inside, and then it goes through and it sends an event to probably the Google Cloud native deploy system, which is called Cloud Build. And the Cloud Build system will then go through and do a deploy. And then that deploy goes into the GCP ecosystem. And really the core idea here is that every time any modification is created inside of this GitHub environment, you trigger a deploy, and most likely this middle step here that we're talking about, you want to do that with a cloud native build server, most likely. And so the cloud native build server would be whatever build process there is available for that cloud. So let's just take AWS. We know that AWS has something called Code Pipeline, and that would be its native build server. The GCP has Code Build, and then for Azure, if you were going to do a deploy, it would have the Azure pipelines. Now this is, and as I was saying before, let's just call this web app continuous delivery. And so this is fairly traditional, and this has kind of been around for a while. And again, I think it's probably worth me just going into this right after this to just show you how it works. I think that this is a pretty well-known process and fairly straightforward, and it's easy to master. And hopefully, let's say right after this, you'll be able to master it. And we'll just put a little tag here that says traditional. Like this is kind of what people have been doing for a while. And now, what's emerging here is this fully cloud native process, and so this would get into the ML platforms. And this really hasn't completely shook itself out yet, but I'm happy to show, I think, even all three today. We could get into all three, but basically with AWS, we already talked about it. SageMaker, the core concept with SageMaker is that you're able to train at scale. You know, this is the train phase, and you're also able to, there we go, that's misspelled, and then you're also able to do the inference at scale, right? And so what's nice about that is that the whole platform itself is managing the life cycle, and SageMaker is constantly reading and writing the data to the data lake. And so that workflow where it scales up and it scales down, it goes through and it spins up inference endpoints. This is really a term that many people are calling now something called MLOps. And in theory, the other picture is kind of like that, but one difference here between like a Flask app and this, and again, I'll use, let's say, the Azure ML Studio, which we can take a look at too. The key difference here is that with Azure ML Studio and MLOps with SageMaker is that they also care a lot about the data and the data lineage. And so what they're referring to is that if you train the model again, you know what changed, whether the data drifted, whether there was new features, or there was an improvement in accuracy, or whatever it is. So this is really a critical component of what's happening in the future, and it's still the cement is not fully dry. But I'll show you what I've actually been doing a lot of work in here. I'll show you everything that I know. So does that seem like a good start to maybe cover the traditional, the classic ML auto deploys, also get into these ML platforms, and then I think I'll also have some time to show some Elastic file system workflows. Does that sound like a decent plan? Unless there's anything else.
Hi, Professor.
Yeah.
So can I say that this platform you are talking about right now doesn't mean that it can separate from our CI/CD architecture, because here there isn't any continuous integration or delivery stuff.
Yeah, then that's what I mean about the paint's still kind of drying on this, is that there isn't a perfect integration yet for how to do this that's as simple as what you would do with a Flask app. And the part of the problem is that there's still a need for things like data versioning and data governance. So SageMaker, there isn't necessarily a perfect story. So let's just look at, maybe let's start there. Let's start with let's see what it can do on both of these platforms. So if I go to SageMaker, for example, and I log in here, let's go to SageMaker. And let's go here. Oh, I need to log in twice. Okay. All right. So with SageMaker, it's a little bit different of a story because they have integrated things around this search interface. And so the life cycle here that they're recommending to you is more, the life cycle is more about a data scientist working with, let's say, Jupyter Notebooks. They decide to do some training. Then they deploy these endpoints. You could in theory also do something similar, where what you do is maybe nightly. Here's one of the problems with doing continuous deployments, and it's a great question actually that you asked. Is let's just talk about what could go wrong with continuous delivery of a ML model. So where's this thing not waking up? Let's go here. Okay. So what one thing that could go wrong is that the model or the data has actually changed. I'm not sure why this thing is, my mouse is freaking out here. Let's try it one more time. So we'll just say what could go wrong. What could go wrong? So we could even set this up into a scenario, and this is actually very similar to the way AWS thinks about it. When I've spoke with people at AWS, is that let's say that you're a biomedical company, and the biomedical company is trying to find a vaccine for COVID-19, right? Let's make it simple. And inside of here, we have a bunch of patient data that gets updated, let's say monthly, right? And so this is February, and then we have another bit of data that comes in March, and then we have another bit of data that comes in April. And let's say that the machine learning engineer is actually using this data, this February data. We'll just say February here, and they used it. They created a distributed training job, and then inside of the distributed training job, it was successful, and then they persisted the model, and we'll just say this is February model, and it looks like things are going great, and then they have some predictions running in production, and maybe the doctors at the hospital will use this data. They'll have these inference endpoints at I don't know, some hospital, and this is great. Things are working. Let's say the accuracy of the COVID vaccine is 95%, and things are great. But one problem here is that the consequences are, in theory, life and death. And what happens if this thing is just always running like automatically? Well, what's one of the things that can happen is that, let's say that the model was, again, running great, but then it turns out that we added a bunch of new data in March, and that data was actually, somebody wasn't really paying attention, and it wasn't collected in a scientifically rigorous way. And then as soon as new data comes here, it automatically trains the data and it puts it out. And then now, this was February's accuracy was 95%. And then because this automatically is deployed in March, now the accuracy is 87%. And even worse is what happens if you weren't paying attention to when the data was ingested, and you have no idea how to get back to what you started before, and you actually had a COVID vaccine that was accurate, right? Does that kind of make sense? So this is essentially an emerging problem that people in the machine learning world are still trying to figure out. So what are some solutions for this? And this is where a lot of the cloud platforms are starting to build these features into this. If I was in charge of this, I would say that maybe one of the things you need to do is actually have control over when you train the model and have data lineage. So you need to know what data was used to train the model, and have timestamps, and also know the algorithms that were used and the people. And so let me give you an example of part of this, which is if we go to SageMaker here and we go to search, for example, and we look through and we look at the search property, I can actually find training jobs that the status here would be equals to, let's say, failed, right? And I look through here. This is one way to encounter solutions for some of this, is to use this historical record here to see, okay, what was the model that I trained, what was the actual data, and then physically look at that data set inside of S3 and see when it was created. So it's not that you can't do some of these same things, because with SageMaker, for example, with Boto 3, if we go to SageMaker, you can absolutely control SageMaker via the API. So you could, inside of a build server, you could go inside of here and talk to SageMaker and do things like create models, create model package, do monitoring, So I think that's the big thing here, is that things are still a little bit murky and emerging with machine learning, and that's why MLOps is a big deal. Now, if the data never changed and it was static and only the algorithm changed or something like that, then you definitely could all you need to do to build a continuous deployment pipeline would be pretty straightforward. Is you could just go through here and call these API endpoints and maybe say, I don't know, if I made a small change to the code, that it re-triggers a training job, and then it puts that training job into production. So I think that's just the main thing, is that these ML systems, they're starting to get new capabilities. So that's SageMaker. Let me show you Azure, because they have a slightly different approach here to this. So with Azure, one of the things that they're doing is that they are building out this Azure ML pipelines, and Azure ML pipelines is something that can handle that data lineage problem. So if we go here, let's go Azure ML Workspace and go to Launch Now. So a couple things to point out here is that because they have built on top of some of the ideas that have come out of AWS SageMaker, one of the things that they can do is improve on it. And if you look at some of the things they have these notebooks, Designer. So this is kind of similar, except for this is a GUI tool that allows you to do drag and drop machine learning. And so if you look at this, you can just essentially run something against a compute cluster, and it will, 32. There we go. We'll say dataset profile. It'll go through and do it in a visual way. Go through and build a machine learning job. But in terms of the continuous deploy process here, go back to home. Probably a more likely one to look at would be some of these other capabilities. So, for example, with data sets, one of the things that you can do is you can actually monitor, and notice as well, this is a preview item, is you can configure data sets to detect the drift between the training set and the inference set. So this is kind of, again, what I was talking about, is it as you're going through and building out this continuous delivery process, this is a critical question, and there isn't a perfect answer yet for how to handle this. But this would be one of the ways that you could do this, is you could select your data set, which assuming is in cloud storage. You then set the baseline data set, and then you set a threshold that shows how much you care whether the data changed, and then to give you an alert. The other one that's kind of similar to this would be that with the models as well, you can also trigger new models being created inside of this pipeline, and so you could actually keep track of that. And then finally, with endpoints, with this Azure ML Studio, you can also, like in this case, I have an endpoint registered. And then this endpoint could be programmatically created, just like we programmatically create things in SageMaker. So you could, because a build server is generic, like a build server doesn't have any preconceived notions about what it is that you're building. You can build anything you want, but the nature of how these things work right now, there's still some things that people are figuring out, and I think that it's actually kind of a fun time, because there's a lot of opportunity for people. And then if let's look at GCP. If we look at GCP here, GCP has something called AI Platform, and AI Platform also you could do some similar things here. Let's do AI Platform. Here we go. So again, it looks kind of similar here, but basically, in terms of the pipeline, you could go through here, create like a Kubernetes pipeline that automatically trains data using Kubernetes primitives. So this is a reusable end-to-end ML pipeline, and orchestrate it. But still, you have to take it into account, the data component of it, and I guess let me just maybe draw that out as well. So one other complication with doing this stuff automatically is that as I was saying before, the data is not static, and so with data engineering in particular, one really good distinction is to think about whether it's batch or online. And we know that data engineering is the raw ingredient for ML. So, for example, if it's a batch-based service, this is much more conducive to doing a continuous delivery process. So you could say nightly, for example, I want to go to this lake and I want to hit some data that's inside of here. Then I want to put that in some new location. So do like an extract, transform, load operation here. And then once that's done, go through and put that into another bucket. And this bucket is basically the bucket that we would use for training the ML. So this would be that section. And now the online is a little bit different in that one thing that gets a little bit more, we'll just call this online/streaming, that gets a little bit more complex is that with online or streaming data, it never stops, right? And so if in the case of the nightly, if you have a fairly controlled environment and these records, you have a handle on it, there's not a lot to figure out with training a new model. It's statically put into this bucket. You have control. You basically decide when you want to train the model, and so this would be a human deciding to do things. Online is a lot more complicated because let's say you have an S3 bucket or something like this, and you have data coming in from, let's say, a game company. And what could be happening is that it's just constantly coming in 24/7, and then you have to make the decision like, well, how do you want to apply machine learning? It doesn't even make sense to apply it in real time to your system, because what if one day you have a different set of customers than another day, and so one of the ways that one solution for this is that there are big data tools that can handle this, and this would be something like AWS Spark, which is their version is called EMR, and Spark ML can do a stream-based prediction, and that might be one way to help solve the problem. But again, with this particular distinction here, this is essentially easy, and then this starts to get very hard, and not that it's not worth doing, but because this data is moving 24/7, you've just exploded the complexity of the problem. So that's another. I think that's another piece that's a little bit tricky to fully talk about when you're talking about a automated continuous delivery system. So what might be easier, it just really depends on what kind of environment you're working in, who you're working with. But I would say, and again, we can do this right now. We have some time to get into this. Is I think that probably it may be worth just getting the continuous delivery of a Flask app down, because you at least can get the concept, and if you go to continuous delivery of Flask, the concept is we could basically just pretend that the model is given to us. So we can basically just say the model is static, and I don't think that's a bad concept. Is to say that the model is already built for us, because we can then focus on the software engineering component. And the software engineering component would be what we've discussed before is you have GitHub, you have a series of files, maybe even you have the model itself is here, and then every time there's a change, it automatically deploys. And what's kind of nice about that is that all the messy stuff that we talked about before, you in a way pretend that it doesn't exist. So you ignore this intentionally, because again, there's a lot of trade-offs, and there isn't a perfect solution to handle how you want to deliver the data. It's messier than software. With software, you could set up things like linting and testing. With data, we're still figuring out some of the things that you need to do. So I think this is probably a good place to start, is to get into doing continuous deployment of Flask apps and know how to master that on one or two platforms using their cloud native development tools. So yeah, maybe that's what we can get into next year, is get into deploying a Flask application on, let's say, GCP. That would be a good one to get into. Let's go to a GCP here and go to this GCP console. So GCP is pretty interesting because it's actually one of the easiest platforms to build web services from. And the way I typically start is I go to the Azure Cloud Shell here, and Azure, the GCP Cloud Shell, and this launches a Cloud Shell that I can use to do development. And a lot of times I'll actually put a virtual environment in there already. You don't have to, but that way I can not have to worry about changing things. But in this case, what I'm going to do is let's just create a new project, and I'll just build it from scratch. So we'll go here, and let's get this thing continuously deployed as well. So we'll say GCP Flask ML deploy, right? So we'll just say this is a project to auto deploy with an ML payload or something like that. And we can just add README, all this stuff, Python. And now this is the part where we would add this checkbox, and this says Google Cloud Build. So basically build, test, and deploy in a fast, consistent, and secure manner. Is we can tell the build server on Google itself to automatically deploy it for us once we get it set up. So got that initial project set up. I can copy this, and now I can just do a git clone here, and then I'll cd into this repo. Okay. Now from here, what I will do is create a virtual environment. So I'll say Python 3 -m venv, call this GCP Flask ML deploy. And notice how it complains about this at first, which is kind of irritating, but I can just do that. I can just say install Python 3 virtual environment sudo okay, that looks good. And here we go. Created the virtual environments. Let me make this a little bit bigger. Okay, create this virtual environment. Now I'll source it. GCP Flask bin activate. So again, to build out a ML application here, or build just a web service, I'm going to CD into here, and actually I don't want to CD into the virtual environment. I want to CD into my repo, which was called GCP. There we go. What did I do? Did I do something weird here? I don't know what I did, but let me do it again. So I'm going to go here, and I'm gonna rm-rf GCP, and then I'm gonna do a git clone. We'll just say history. Let's just recreate this. I don't know. I must have done something stupid here. So I'll just clone it again. There we go. Okay, so I got this repo. I'll CD into there. And then I'll do the virtual environment. I think I didn't put the dot on it, which I like to put the dot so that I don't make a mistake like I just did. So yeah, so this is what I messed up. And this is exactly why I put this tilde dot typically, is so that I don't create a weird directory that's confusing. I don't know what's going on. Okay, created that. I'll source it. And then we'll go through here, bin activate. Great. If I say which Python, it's a Python that's in this virtual environment. Everything looks pretty good. So the first thing typically though that I would do is I would create a new project inside of GCP. So I think I can still create projects. Hopefully they don't blow. I've created so many that they get upset, but we'll call this Flask ML deploy. That looks good. And there we go. And typically, because I mean, there's a bunch of different ways to change the project, but notice how the old project is here. So what I do is I will go to the new one, and then I will just close this shell and open it up again because I'm lazy and I don't want to. I don't want to change the project name. And I can also deactivate this because I had a shell that opened automatically, and I can resource this thing. Okay, so we're in pretty good shape here. We got a virtual environment. We got a project created. I've got the project checked out. I can see CD back in there. So I've got a decent setup here. So really the only things that I would need to do is create the scaffolding really quick, so that I can have a structure and then start to build out the Flask app and then deploy it. And we can do it very, very quickly. So first up, I'll go through here. I'll create a make file. I'll also create a main.py, which is, I think, the name of the file that you need for Flask on App Engine. And then I'll also create a app.yaml as well. And I think that's all we need. Oh, and then also requirements. So these are all the things you do. I'm just from memory remembering these. If you don't have these, you won't be able to deploy. So I'm going to go to Open Editor, and I will add some values for each of these 4 things here. Okay, so let's see. I'm going to go to GCP Flask ML, and I can actually look at an old project as well. I can look at one I was just working on earlier. In fact, I can just copy. So this is Python 3.7, sure. So I'll put that inside of my YAML. Although let's just use Python 3.8 because that's the newest one. So we'll say Python 3.8. All for the main file as well. I can just copy some of this code, but I'll just take the majority of this out. I'm just going to say, take all this stuff out here. And first I'll just make a hello world route. And let's just get this going. There we go. Okay, so we got a hello world here. This looks pretty good. And I also need to go to my requirements file, and I need to add inside of here Flask. And I think that's all I need. And then, and if I wanted to, inside of a make file, if I wanted to be kind of tricky, which I do like creating make files, I could do an install, and I could say install local or something like that. And then I could do, a pip install -r local requirements. And then if I wanted to put just things that I need for like development, like pylint or things like that, I could keep those separate from the app that I was actually building. So let's actually go back to the terminal, and I'll say touch local requirements like that. And then so I basically could have two kinds of requirements files. And so this one I could put pylint in, for example. Okay, that looks pretty good. And that looks pretty good. And so I think it's ready to go. I think if I just close all this, I can essentially get this running. So go to the terminal and say, I guess if I want to use the make file, let's just be consistent. And let's go to the make file, and we'll add a command here that says install. And then I'll say pip install -r requirements. So the key differentiation here would be that by adding this local install, this allows me to separate the local shell from what will later go on to the deployed environment. So we'll go through here, and now I'll just say make install. And let's just, I know what I messed up is this has got to be tabs. There we go. So I got to go back, get rid of these. There you go. Just make sure those are all good. Okay. Looks like that's saved. Okay, so we've got this running here. And then if I just say Python app, Python main, there we go. We got something running, and I could go to this preview icon, which is pretty neat. It's by the way, a complete copy. Azure and Google Cloud Shell are basically copies of each other. Let's preview this. There we go, hello world. So we got something working, but to make it more interesting though, we really need to first deploy it and then get it auto deployed. And then if we have some hooks in here as well for machine learning, then we could get a full ML pipeline working. So let's actually deploy this. And if I remember correctly, I think you just say GCP app deploy. I think it's, or is it, what is, I can actually look. I have an application here that I have all this documented called GCP Hello ML. Let's look at this GCP. Yeah, here we go. G-Cloud app deploy. So that's what we would put locally here. Is this G-Cloud app deploy. And what this does is it initializes a new region where I would deploy this application. Let's just say US Central, so 14. And then it takes a few minutes to get this, all wired up and running, and then it'll deploy it. And so you can see this is where it will put that. Hopefully it's actually quick. Maybe it's going to be quick. Let's see this one. Now, notice the app.yaml file is critical. If you don't have that, it won't work. That tells it what the runtime is. And then again, this will be the location where it will run in production. But this is only part of it. The other part that we want to get figured out is the auto deploy with their build system. So we can also do that. And so if I remember correctly, this project that I think I had cloud-build.yaml. I had one of these cloud-build.yamls. Cloud build. Yeah, I think I can just look at this and see. Yeah, I can basically just kind of mimic this thing and put it in here. So while that's working, I'm gonna build another file here. So I'm gonna inside of this, I'm gonna say new file, and we'll call it what was it called again? It was called cloudbuild.yaml. So cloudbuild.yaml. So cloudbuild.yaml. And hopefully it's YAML. And I think I added a bunch of stuff I don't need. I'm going to take rid of all this here. Get rid of all this. So only thing I need to really deploy it, we can add linting and all that stuff. That's a different thing. But basically, I believe you just need to do this. You just need to say, run the same command that I'm running locally here. Just do it inside of this cloud build process. So let's test that out here. So what I'm going to do is I'm going to take this thing and just first verify that it actually works. So does this work? And hopefully it does. And then this will deploy us there you go, hello world. Now, the other thing that we can check here is that we can see if it's actually what it's actually returning and do that kind of stuff. So let me just make it a slightly more complex here, because what I will do is I will add a little bit more code to this first. So let me go again to the editor, and let's just add something that's a little bit more, I don't know, like, again, we'll just say app.route, and we'll just say name, and this will just, whatever you put inside, or we'll just call it echo, actually, there we go, echo, and then we'll say name, and this will just echo out what you put inside of here. And so this will be name, and we'll just say print this was placed inside in the URL, and then we put the name in here. There we go, got that. And then I can actually return JSONify name, I think. Yeah, I think this will just return back a JSON version. I think I can actually do this, if I remember correctly. You can do, let's go back here for JSONify. I'll just look at one of my examples. Doesn't really, let's see, yeah, like this, something like that. There you go. So we'll go back here. That looks good. Not sure why that's saying there's an issue, but basically we can do this. We can just say JSONify. So for value, we can just say name, and name. Okay, JSONify value. So let's just double check that that works real quick. So let's try to echo this. So let's say Python app, Python main. Looks like it still works. And if I go to the web browser, we can see that that does echo John. There you go. Okay, so this thing works. So now if I want to change it, and look, we can see that it prints this out. So if I want to change this, the nice thing about this GCP-based deploy system is that it really is trivial to deploy your code inside of here, and it's not bad at all. And so what I'll do is just run this GCP app deploy. And it will update this thing again. Here we go. Do you want to continue? We'll say yes. And then this should do an update. And again, what's nice about this is that it is a pretty easy workflow to test out a Python application. And if you are doing a static form of machine learning, it's not bad. It's a great process to deploy changes, and it's reasonably quick as well. There we go. So got this thing working, and we can go over here and go to this. And if I go to this URL again, we should have hello, but now I can actually test out echo and just say Marco. There you go, Marco. So I got an echo server, John. Okay. So to do the full deploy now, that would be the next step. What I would do would be to go to the build server and get that hooked up. So in order to do that, I'm going to go to the cloud build here, cloud build right here. In cloud build, I can just set up a new trigger, and I can say connect your working project to start building a Google Cloud Build project. Here I say Cloud Build GitHub app. Pull requests are supported. So click on this thing. It's going to say authorize. And from here, I just have to tell it which project I wanted to deploy. And I think I called this thing, what did I call this? GCP Flask ML deploy. So go back here, GCP Flask ML deploy. So I'll click on this repo. I understand that this costs me money. Sure. Here we go. And then I can say create a push trigger. And so a push trigger runs a build every time you push a code change to a branch. And so that's what we want to do. We want to, every time I push a change. And now, in theory, I could even edit this project and tweak it and in GitHub, and it'll auto deploy. But let's actually test this out a little bit and make sure that this thing is actually working the way that I think it would work. So I'm going to first say git status, and you can see there's a bunch of files here, and I'm going to change them. So we'll say git add makefile, git add app.yaml, git add cloud build, git add local requirements, git add mean.py, git add requirements.txt, and let's see, adding files for auto deploy. So in theory, this will trigger the build, and this will deploy the app again to production. And so we can actually just watch it in action. So we can just say it's enabled. Let's click this and look at the dashboard, and we can see that I think, there we go, it's actually building, and it's got a problem. So I probably screwed up the build process or something. So what does it say? It says you already have an image. Oh, it says that this App Engine API is not enabled. Would you like to enable it on this project? So what we have to do is actually tell this project that I need App Engine to actually work on it. And I think I can just, this is always the part that's irritating about this build process, is I have to enable the build server to be able to deploy. So we just say enable this. So this enables you to programmatically talk to and manage the developer API. And I believe that should work. So let's try it again. Let's do a retry. Let's see if this works. So starting build. Operation complete. Please make sure that you're using the correct project ID and you have permissions to view applications on the project. So, not sure why that's giving me that error as well. Let's see here. GCP. Let's just double check this real quick. I don't want to spend too long on this, but there's just little boring things that you have to do when you first set this up that are annoying, and then you get it set up. So auto detected. That looks like it's set up here. View triggered build. Yeah, this looks like it is correct. The cloud build executes builds with, maybe this is the one that I need to enable. Cloud build. Execute builds. I think this is the one that I had to enable, was App Engine admin. So I'll try one more time here. If not, I'll Google it. But let's run the trigger again. Let's go to dashboard. Okay, so it's running it one more time. Hopefully this time it works. Okay, so is this going to work? At least it's taking longer. Step there, that looks good. That looks promising. That does look like it's doing something. Oh, there we go. So it worked. So it took about a minute. I just had to enable the API, which I don't know why I didn't do it the first time I did it. But so this is actually great. We got this thing working. We got continuous deployment cooking here. Now, the piece that really would test it out, though, would be, let's actually make a change to it. And so first, let's just verify that it still works and it's what we think it is. So I'll go here, and again put this in here, and it's still working, hopefully. Yeah, it looks like it works. And then if I type in echo, I can say Jill. There you go. Okay, so this thing still works, but the most interesting scenario is we want to change things like dynamically. And in fact, if we're really lazy, I can just go back to GitHub here and go to this application, and I can even write the code inside of here. Now, I think just for speed's sake, they're probably, I don't want to get into too much putting machine learning code inside of here. I have another one that I can show, but just for speed's sake, I would say let's just make this slightly different. This was placed in the URL, and I could say, I don't know, new name or something. New name, and then this was placed in the URL. I would say, like, I'll just add some kind of character. Now if I make this change and I commit it, this should instantly go through here and build the process. There we go. So we got this thing cooking, and again, it's going to go through here and run the changes and auto deploy it, and it should be pretty quick this time because I think it's all warmed up and it's ready to go. So that is actually full continuous delivery of an application. So yeah, maybe, since this was one of the questions that somebody had, any questions about does this continuous delivery process make sense?
Professor?
Yes.
Yeah. So did you set the trigger was like push to the master branch so it will auto deploy, and so I can like push to something like a test or other branch. I can see if it works. And after that, I'll push to the master to deploy.
You could absolutely do that. So you could set up. That's how typically I would set something like this up. But in this place, notice that I said the trigger. I said push to any branch, but we could specifically put a different trigger and slightly tweak it and put, like you could say push to a branch, and then which branch, maybe we just say only master here or something like that, or staging or whatever it is you called your branch, and you could have a slightly different build trigger for each build process. Yeah. So but just to kind of intentionally keep it simple, to not put any ML in there yet. This would be a full continuous deployment. And so then where would the ML component go? Well, then all you would need to do is, if I go to the, let me show you this other Flask application here, would be that if I go to this application, this is one I did just recently, that you could just tweak it a little bit and add some code like this, and then inside of here put the payload into the Flask app and tell it to load it off of disk. Now, this would be an interesting question for someone that wanted to automate this, is that in theory this could be the MLOps component, is that model. So let me just whiteboard this out real quick. So I think that, so I'm glad we got one thing. We got the continuous delivery, full end-to-end, pretty straightforward to get it working. And we can actually also do it on Azure as well. It's pretty straightforward to get it going on Azure. But the idea here would be that if you were able to break the problem, let's take the ML engineering and let's break it into two pieces. You could actually have what we just went over, which is the CD pipeline is not bad. I mean, it's pretty easy actually to create a CD pipeline. And then the magic component though of the Flask app was that one command, which was to grab the file, which is the serialized file. So this is interesting in that maybe you could have a separate, either call it a data engineering pipeline or an MLOps pipeline, or whatever you want to call it, whatever buzzword. And from here, you could have something that decides the rules of how this model is put into, let's say, a cloud storage bucket. So this would, I think, be the piece that's there isn't a perfect answer for, but it could be that let's say nightly a new model is created, and then let's say there's a QA process that's human. Maybe there's a human QA process. Someone goes through, they look at the model, they make sure it works properly. If it works properly, almost like a pull request, you could put the model into the location where the auto deploy occurs, and then it auto deploys the model, right? So you could automate a lot of it, but I think this is the piece that really there isn't a perfect answer for right now, and maybe there'll never be a perfect answer, which is because there's that expression that's called garbage in is equal to garbage out, is that you want to be very careful about how this model is created and what are the implications for it. But I think a decent scenario, if I was building a data science team, is I would have the data engineering team, maybe they have a weekly goal where the weekly goal is to validate new models. And they could use any tool. They could use, AutoML. They could use, manual ML or whatever. And they could put these models into a location once they're verified, and then the ML engineering component of it would pick up the model. So basically, as soon as, let's say, the data scientists and data engineers got together and they say, okay, yep, on Friday we're going to release a new model. They put it into cloud storage. They literally make a put request or whatever, put it into there. Then it would trigger the deploy, and then the continuous delivery pipeline puts it into production, and then you do a prediction. Does that make sense? And any questions about that?
So do you mean that we can add a process that's due automatically, but using a value set for the auto-trained model to see if it's better than the current one?
Yeah, exactly.
Then put it into our model.
Exactly. So this could be fully. It's almost like having a self-driving car. Well, that just because you have a self-driving car, it doesn't necessarily mean you want the car to drive by itself all the time, because the human has to take over. And so if you set up this continuous delivery pipeline like we just set up, it could do something really well. Like it could have automation that automatically deploys it. It's great, but then still you want to be very careful. And you could have a lot of automation, including you could have AutoML where you create it with Azure AutoML, or you use Google AutoML or something like this. But still, I think you want to check, like you said, and see, is it even better? And also, is this something the company wants to be deployed into production? If it is, great. And then just put it into a location, and then the automatic deployment process deploys it. I think that's probably one of the safer ways to do machine learning at scale. Maybe there's other ways that other people would do it, but that's how I would do it. Especially if it's a critical ML model. Now, if it's just recommendations for like which web pages to visit, maybe it doesn't matter. Maybe you want to, be more cavalier about it. But I think if it's something that's important, there should be some level of human QA again, just like a self-driving car, even though the car could in theory drive 100% by itself, there are some edge cases that you should be aware of. And there's many cases people talk about where a human dies behind a Tesla because they were using the self-driving feature and not paying attention. So maybe then the next thing that, since we got into this topic and ML engineering is kind of a fun topic, let's now see how to do this with Azure, and let's see how far we can get and even deploy the ML model with Azure. So I'm going to go back to Azure here, and what I will do is go to the app services. So this is like it's kind of like their version of App Engine. And I will just make a new app here because I think I already have one running in production. So I'll go through here and I'll just say cloud storage, and we'll say instance details, web app name. I'll call this Flask ML at scale. And I will just put a code version of this. For the runtime, I'm going to pick Python 3.8. Let's see, or Python 3.6. Let's do Python. Sure. Let's do Python 3.8. Central. This looks good. Review and create. Okay. Let's go ahead and create this. Okay, so this is now has an environment set up for me, and if I remember correctly, I can just open up a shell, which and again looks very, very similar to how it would work inside of the Google Cloud Shell, and I've got all these resources set up. I can pin it here, and what I would do is then just create some files, and I think I actually have one. Well, I can just check this project out again, I guess, or I can. Let's see what I can do here. I can just say make a directory called Flask deploy. How about that? And then I will just check this out. Let's go here. And let's just go to this application, copy it, close all these up. Okay, so git clone. Okay, so now that I've got this thing going here, I'm gonna create a Python 3, although I think this one has a weird version of Python on it, which makes it a little bit irritating because it runs an older version of Python, which is not that big of a deal actually. But let me just double check that I don't have any Python. Yeah, I don't think I have any Python 3.6 syntax. Okay, that's good. So I'll just create a virtual environment. So I'll say Python 3-m venv tilde /dot. We'll just call this Flask deploy. Source it. Flask deploy. Bin activate. Not sure why this thing is locking up here. Every once in a while it'll do that. There you go. Bin activate. Oh, Flask deploy. I need to say source tilde Flask deploy bin activate. There we go. Okay, so now that I got this inside of here, I can say make install. This will install all the things I need. And then I can do a very, very similar process that I did with Google App Engine. In fact, they're almost identical. And except for in this case, there's an actual machine learning application. Okay, so here, what I can do is I think I called this one app, so I'll just say Python app and just double check that it works. Okay, so that thing works on port 5000. And if I go to this thing, I think, yeah, web preview, it will let me just call the main endpoint. And so I think I can just say configure port 5000, open and browse. There we go. So we can see that I'm able to actually call that web server. So this thing looks like it's good to go. Now, how do I deploy this into production? All I need to do is, let me look at my instructions here. This is wrong app. Sorry. Which one is it? This one. Okay. Is I can just look at, so this is what it's going to do. Is we already checked it out here. I'm going to skip this Azure pipeline step for now, but I'm just going to do this. I'm going to pretend like I'm Azure pipeline for now, which is similar to Google Cloud build, and then I'm going to deploy this into production. So what I need to do, if I remember correctly, is I need to say this. I need to say AZ web app -in your service. So let's go through here and let's do that. Let's bring this closer. So I believe that I call that other service this. What did I call that thing? Your deployment name is go to resource. What is it called? Oh, Flask ML at scale. There we go. That's our service. Sure, that works. So I just say, basically, it looks inside this directory, and it's got some kind of a problem. It looks like maybe it already exists. Here's the traceback. Not sure why that's got a problem, to be honest. I don't know why that thing's having issues, but let's pretend that it did work, because I have another version working. I'm not sure why this thing's got problems, but I'm gonna go to I already deployed this app locally here a while back, so I can just do it again. So I'll go into the one that does work, which is here. I think it was under Azure DevOps. Go to this one now. Where was this thing? ND082. Let's try this. C2. Maybe this is it. I think this might be it. Yeah, I think that was it. But let me just go back to this real quick. Flask deploy, Flask ML serverless, and I'll just go to history. I think I can just call the other service that I had working, and that will do it. So go here. There you go, source. And I can just do that same command that I did before, but I'm going to change it to an existing web application that I already have working. which I think I should just be able to say web app up. And if I go back to the web apps, the resources, I should be able to go to app services. And I think it was this one, Flask ML. Yeah, so let's just say Flask ML. Let's see if that works. Web app up. Was it dash in? Already exists. We'll deploy contents to existing app. There we go. Okay, great. So something worked. So basically, again, it's kind of similar to the Google App Engine. Is it looks inside the directory. If there's an endpoint available, it automatically deploys it. Now also, if I go here, that would serve out the empty route, and then to test the prediction, I think I have to wait for this to finish deploying. I can actually do a prediction, which I'll verify in a second. Don't know why that's. Maybe it's because it's deploying right now. I think if I remember, this is pretty quick to do an update. I probably should have waited to do an update before I redeployed. But in general, while this is waiting to see if it everything works here, the core concept still is this, which is that you build this CI/CD pipeline that listens to your Flask app, and again, this model could be created from somewhere else. The piece in this part that's a little bit tricky, which I did document here, which I don't think we have time to get into, is that, see this thing, this Azure DevOps, it really is not a fun service to work with. It's actually very complicated. But the way you would set it up is you go to their build server, you click these buttons that kind of hook up to the different parts of Azure. You put your subscription in there. You then create a new Python pipeline with GitHub integration. And then the same thing, when you make a change to GitHub, it will generate this for you. It'll generate a gigantic YAML file, like a huge YAML file. And then it will go through and deploy. And this is actually a video of the actual process. And if you want to, you could actually add linting and a process to it. But in a nutshell, that basically is what would happen next. So I don't know how long this will take. So just so we don't burn up too much time, that's probably a good thing to show in terms of at least the Flask side of things. And then on AWS, fairly similar as well. The big difference on AWS, if you wanted to do Flask-based machine learning, would be you could again do something similar. You could use the cloud build, the code pipeline to do the deploy, but also you could use something called Elastic Beanstalk, which isn't as friendly as potentially the app services. But if we go through here and I say web server environment, I could say select, and we could say like Flask ML. And from here, you would put all this stuff in here. Sure. Manage platform, choose a platform, Python 3.7, upload your code. Here we go. I could say, where do I want my code to live? I could put that into either a public S3 URL, or I think I can tell So basically in this particular example, this could be your MLOps workflows. The code build itself could put the assets into a S3 bucket, and that S3 bucket could include the Flask app and the machine learning model itself. And then every time there was a change made to it, it would trigger it, and it would go through and build this itself. So basically, in a nutshell, this is how you could deploy something using Flask. There's too much time to spin all this stuff up, but it's similar to this other Flask Azure app. Okay, so I got this thing running. The other thing that I could do here is I could also just show you that it actually works, just so you can see how this works. So let's see, that works in theory. In theory it works. Maybe it doesn't work. Or it's running on a different port. Actually, let's see. Make predict Azure app. What does that say? Port 443. Oh, it's port 443. Okay, so let's see if this works. So this is a prediction. Let's just run this. Oh, and then this app name would be make predict. Let's just put this here. And I believe that this one would be called Flask. Oh, so it does actually work. There we go. So that is working. And this would be this. So does it do machine learning prediction? It runs it to port 443 and it makes a prediction, right? So we do have a full end-to-end machine learning pipeline. And again, if to do similar to what we did on Google App Engine, you would just set up what I put into these instructions in this document here, which is set up this Azure DevOps workflow. The problem with it, and why I didn't want to go into it, is that it's not non-trivial. You have to click like 30 buttons to get it to work, and it's just a pain, and it's a little bit buggy because it's in preview. I'm sure they'll make it a little bit smoother. Probably the only other thing I was gonna, I guess, yeah, since we went on a little bit of a like a narrow focus here, was there anything else in machine learning engineering that I didn't explain that you think I can make more clear? If not, I could talk about maybe storage or some other concept that I was going to get into. Not sure why my camera is. Oh, there we go. Kind of was, my camera had gone to sleep or something. But so let's just maybe put a pause on that Flask ML process, and let me just tell you a couple things about storage that might be helpful, and we'll just maybe whiteboard these up. So the other thing that I was gonna talk through a little bit today, that you can go through in labs, either on Google Cloud Lab or for the Azure Microsoft Learn or the AWS Academy Labs. But basically in cloud, there's a few different storage types to consider. So cloud storage, and in general, you should be aware of the object storage. And typically the object storage is what you use when you want to build a data lake. And so object storage and data lake are the things that people are putting, essentially infinite scale data will live inside of the object store. And on AWS, it's called S3. And then on Google, they call it cloud storage. But anyway, they're all similar in the clouds. And the other one after that would be the block storage. And so in terms of block storage, what's important to be aware of is that this would be essentially like mounting a volume. Mount a volume, and the volume itself would be like a mount point on Linux. So you could go through and you could say like /mount, and you could actually provision even disk IO to it. And you could create snapshots. The problem though with the block storage is that only one machine can communicate with it. So AWS calls it EBS, Elastic Block Storage, and it can do some pretty cool things. Like you could give it, let's say, and I've done this before, like 100,000 IOPS of storage or of disk IO. But in general, it's got some limitations where an object store has some advantages in that you can give it a bunch of different workers, like for example, EMR, Elastic MapReduce, which is Spark, can launch tons of workers, and the disk IO will just scale. Where this you have to control the disk IO yourself for the most part. The other one that's a kind of a newer one, that's an interesting one, is EFS. So Amazon EFS stands for Elastic File System, and what this is a NFS mounted storage. It's actually my favorite because one of the things that you can do in a high performance cluster, and I've done this before, is that each of those could mount the EFS volume, and they all have the same home directories. They all have the same storage, and so you could actually deploy software very easily, rsync, AVZ, using, let's say, 1 second deploys or something like that. You could just sync your data to the storage point, and then all of the high performance nodes can mount it. And then the other kinds of storage that are somewhat relevant here are the or maybe just talk about databases. So in terms of DBs, you've got graph databases, you've got key value databases, you have the relational database, you have search databases, and in terms of storage, those are probably the main components that you're dealing with. And so this is where machine learning really plays mostly. So we'll say 80% of ML happens in the cloud storage, because things like the machine learning platform SageMaker, or the Elastic MapReduce, the big data tools, or Athena, which is a ETL tool. So Athena is an ETL tool. These are all really focused on the object storage. The block storage isn't really something that is used as much in machine learning, and I would even call this in a way like a legacy storage system. And the reason why is that it's associated with virtual machines. So a block storage and virtual machines are very similar. They're tied together because it's a virtualized storage, where this one seems to be where all the traction is headed. And then also Elastic File System, I think, is also potentially could be taking over for block storage, because why use something that you can't share with other people and you have to manage it when you could just mount a storage device that, by the way, this will grow disk IO as well, and it'll grow size. So you don't have to manage the size, and you, just like S3, you can, and everybody can talk to it. So really this is in a way kind of a legacy system. And then with the databases, the main takeaway with the databases is there's a lot of different kinds of databases: graph databases, key value databases, relational data, search databases. So that's the lay of the land with the cloud storage. Any questions about this cloud storage that that I could clear up? So let me then talk about the ETL tools. So the next thing in terms of cloud storage would be ETL pipelines, and with ETL tools, ETL pipelines. Again, most of the ETL stuff is going to also revolve around something like S3. And why is that? Because we know that this is infinite or near infinite. So it's got disk I/O. It's got the network is theoretically near infinite. Storage. It's got security requirements that are great in here. But how does this ETL pipeline get, if you get, let's say you get 14 terabytes of data, which is actually nothing. I probably have that much in my house, but let's just say it's 14 terabytes of data. How do you even know what's going on? There's like all kinds of data all over this. Well, one way is you have serverless ETL pipelines, and the serverless ETL pipelines are available with a service called Athena plus AWS Glue. And the way it works is that, and I think we can cover this real quick, is that you tell AWS Glue to essentially like crawl the AWS S3 bucket and then create a catalog. And then once it creates that catalog, what it can do is Athena can now do SQL queries on that catalog. So it doesn't have, so you don't have to have servers that are spinning up, doing all these kinds of things. You just have a process that let's say once a night goes through, looks at all the different things that are in S3, and then you have Athena go through and query it. So yeah, maybe we can just look at that real quick and highlight it. So if I go to my Glue process, you can see there's a fully managed ETL. I can create a new table here. We'll say add tables using a crawler. So again, it can just crawl S3, and we'll just say, test crawl or something like that. We go through here and we say data stores, and then choose a data store. So it can choose S3, which is probably where you would want to spend most of your time, but also can talk to an external database. I've actually done this before with like a Postgres database in a data center in Germany or something like that. You can just talk to it, pull all the data, and then dump it somewhere else. In this case, though, we'll just say S3, and then say for connection, this would be, I don't think we need to mess with that. Crawl data in, specified path in my account, and I believe I can just paste in the bucket. Let's just use that, web scraping. There we go. No, don't want to add another data store. And I think I can choose an existing role here. And then the frequency, this would be the part where you would do a data pipeline. This would be the process where you would literally create a data pipeline from scratch. And so again, in this particular scenario, I'm just going to run on demand, but you could maybe run it every night. Choose a database to contain the tables. I think I can just say one I created earlier. Let's go here and go to next, finish this, and we'll run this. So if you look at some of the ones I've done before, here's one I did a long time ago. But basically this, I think it'll show you the metadata. Where does it put the metadata? Tables. Databases. There we go. So basically under, I might have deleted a bunch of my tables here, but basically it, or no, I guess I didn't. I was filtering wrong, but basically it will find the fields, the properties, schema, put it all there. And once it does that and it creates this index, you could also do some other thing. You could create like an ML transformation or do these other things, clean your data. Or what you could do is you could go to Athena, and then in Athena, you could actually do lazy queries on the data using that catalog that you just created. So if I go through here and I say, get started, I could look at the data sources that are available. And so I could say connect to data source and say, I want to go to a glue catalog, set up or I can add it manually. So you can either set up a crawler, which I just did. I could have done it this way, or this will actually just go and find one of those crawlers. Like, I don't know which one of them would be a good one, but one of these things, I can put a new table and it will go through here and build all that together. So in a nutshell though, the main thing here is that you can actually run SQL queries on the data. Let's see if this one will work. I might have deleted that, but basically you can run SQL queries based on the index, and really it eliminates a lot of the kinds of processes that people in the old days would have servers running constantly and moving data from a relational database and back and forth. And so in a nutshell, I think this is one of the more powerful, ETL pipeline workflows is the serverless pipeline. And GCP has the same thing with their jobs pipeline as well. Probably the more flushed out one right now is AWS typically has the most services.